So in this set of notes, we're going to be investigating and graphing systems of inequalities. So instead of having one line with shaded region, we're going to have two. So we'll have two different inequalities, each that will have its own line, each that will be either solid or dotted, and each that will have its own shading. So this Desmos activity on page 1, we'll come back together and look at tomorrow. So in the meantime, we're going to jump to page 2. So go ahead and do that. So what's going to end up happening is we're going to take our system and we're going to graph them both at the same time in the same coordinate plane. One thing that can help us is that if we have different colors, that can potentially help us see the overlap. But if you do just have pencil, you could always do one in like one direction and then do the other in the other direction. But the key is that we want to treat them as each their own entity. So here's my system. Y is greater than negative x minus 2, and y is less than or equal to 3x plus 6. So the first thing I actually want to decide for each of these, just to help keep me organized, is if the line is solid or dotted. Now, since my first inequality is just greater than, that means the line is not part of the solution, and so that means that one's going to be a dotted line. I'm also going to make a little note there. And then my second one, since it's less than or equal to, that or equal to part means that it's going to be a solid line and that the line is going to be part of my solution set. In both of these cases, since y is isolated, it's going to be the most efficient to graph them using slope-intercept form. So I'm going to begin by graphing my y is greater than x minus 2, and I'm going to start at my y-intercept, which is negative 2. And then since my slope, which is my number in front of x, is negative 1, that means that from my test point, I'm going to go down 1, right 1. I'm going to keep doing that. And I'm going to do that as many times as I can to make it easier to connect my points with my dashed line when I'm ready. And so now that I'm ready, I would take my ruler and I would connect these points with a dotted or a dashed line. And so what that represents is that this is my boundary line. And so now I've either got a color on this side or I've got a color on this side. And to do that, I'm going to find the truth using my test point. So my test point is going to be 0, 0. And I have some room for work right here, which means I'm going to be replacing both y and x with 0. So here's that original inequality, and so then it's going to be 0 is greater than negative 0 minus 2, which is going to be 0 is greater than negative 2, and that's true. So that means my origin is part of my solution. So I'm going to color in this side with red. Now, what we did yesterday was a single inequality where we only had one of these. Now I'm going to add another one to my graph, and I'm going to add it in blue. So in order to graph this inequality, I'm going to start at the y-intercept, which is 6. And then according to my slope, I should rise 3 and run 1. But I don't have room to do that, right? I'd want to go up 3 and over 1 from this y-intercept of 6. So instead, to keep it positive, instead of going up and to the right, I'm going to go down and to the left. So from this y-intercept, I'm going to go down 3 and left 1. And I'm going to keep doing that until I run out of room. And now I want to connect that with a solid line. And so that looks like this. Now I also have to pick a test point for this blue line, and the origin is also available. So that means I'm going to be replacing x and y with 0 and 0. So 0 is less than or equal to 3 times 0 plus 6, which is going to get me 0 is less than or equal to 0 plus 6, or 0 which is less than or equal to 6, and that's true. So that means for the blue line, I'm going to shade on the same side as the origin, but I want to shade that blue line as if the red line doesn't exist. And so what the solution is it's this part of the picture here where the two shaded regions overlap, but it also includes this portion of the blue line since it's within the red shaded region. This portion of the red line doesn't count since it's a dotted line. For example 2, I'll start by graphing the first equation, and then you can do the second one. That's when we'll pause. So again, I want to start with solid versus dotted. So I notice that this is less than, so that's going to be dotted. And then my other one is greater than or equal to, so that's going to be solid. So I want to make sure I use those types of lines. For my first system, I'm going to start it at the y-intercept, which is negative 4. And then according to my slope, which is 1, I'm going to rise and run 1 and 1, do that as many times as I can, and then connect it with a dotted or a dashed line. My origin is available, so I'm going to go ahead and test that. 0, 0, which is going to get me 0 is less than 0 minus 4, which is 0 is less than negative 4, which is not true. 0 is the bigger number, so that means when it's time to shade, I have to shade away from the origin. So at this point, what I want you to do is I want you to pause the video. I want you to graph this blue inequality. So put your points on the graph, make sure you're connecting with a solid line, test your test point. Based on true or false, either shade with or without that test point. Pause the video, press play when you're ready to check your answers. Okay, so in order to graph this line, it has a y-intercept of 3, which means we're going to start up 3 on the y-axis. And then it has a slope of negative 1, so we're going to go down 1, right 1. We do that a bunch of times, and we already made a note that it's going to be a solid line. And our test point was 0, 0, so that means both y and x get replaced with 0, and so that's going to say that 0 is greater than or equal to 3, which is false. So when it's time to shade, we're going to shade on the opposite side of the origin, and so then the overlapping shaded region here is where our solutions are located. So that means anything in this zone, anything on this section of the blue line, but not on this section of the red line are going to be solutions. So on page 3, I'm actually going to start with example 4, so let's go down to that one. And if we start with the first inequality, I notice that it's greater than or equal to, and so that means that it's going to be a solid line. And the second inequality has less than or equal to, which means that one's also going to be a solid line. So my first inequality, I notice, is in slope-intercept form. So I'm going to graph that beginning at the 2. As the y-intercept. So I'm going to go up 2 on my y-axis, and then this one has a slope of negative 1, so we're going to go down 1, right 1 to find all of our other points. And we'll go in the opposite direction as well, and now it's time to connect with our line. Once I've got that, I'm going to use my test point, and the origin is available. So 0, 0. Remember, if the origin is not available, just pick something else. So if it wasn't available, I might try 1, 1, although that's not available here. I might try any point that's not on the line. So I'm going to replace both y and x with 0. So I've got y equals negative x plus 2. 0 is greater than or equal to negative 0 plus 2. 0 is greater than or equal to 2. That's false, which means I'm going to be shading on the opposite side of the origin because the origin was not true. Now for my second line, I'm going to graph, instead of using slope-intercept form, I'm going to graph using x-y intercepts. So over here, I'm going to treat this as the equation x plus 2y equals 4. Remember, an x-intercept means that it lives along the x-axis, which means that it has a y value of 0. So to find the x-intercept, I would change y to 0, and if I make y to 0, that makes my mini equation x equals 4, which is going to be here on my x-axis. To find my y-intercept, that means that it lives along this line, which has an x-coordinate of 0. So if I make x 0, my mini equation is 2y equals 4. And if I divide by 2 on both sides, I get y equals 2. And I'm also going to connect that with a solid line. Going to look something like this. This one also has a test point of 0, 0 available because it's not on the line itself. So that means I'm going to change x and y to 0, which is going to get me 0 plus 0 is less than or equal to 4. 0 is less than or equal to 4, which is true. And so then for the blue line, I'm actually going to shade it on the same side as the origin. So that one's going to look like this. And so then all the points that would be solutions here would be all along this section of the red line, all along this section of the blue, and then everything in between where there's an overlap. So at this point, I'm going to have you try example 3. Both of these happen to be in slope-intercept form, so graph them by starting at the y-intercept and then rising and running. When you get to this one, be careful. Your test point won't be able to be 0, 0, because that's actually where your graph is going to start. So you'll have to pick another test point that's not on the line. Pause the video. So you're going to graph both lines, solid, dotted, start at the y-intercept, rise and run, test point. You should have 2 overlapping shaded regions when you're done. Press play when you're ready to check your answers. So for my first inequality, it's greater than or equal to, so that's going to be a solid line. I started this graph at +1, and then I went down to run 1, down to run 1, because that slope was negative. My test point was 0, 0, which produced a false statement, so that meant for the red line I had a shade on the opposite side of the red line. For my blue line, I started at 0, since that's my y-intercept. I rose 3 and ran 1 in both directions. Now this time the origin was not available, so imagine if the origin had worked, I still wouldn't know which side to shade on, or if it didn't work. So I have to make sure my test point is clearly on one side or the other. So I picked 1, 1. So I replaced both x and y with 1. 1 is less than 3, so I shaded on the same side as that test point. So begin on page 4 by graphing this system here. Make sure to choose solid versus dotted. Graph them both using slope-intercept form, and then shade. And then from there, we'll answer these questions below. But pause the video. Press play when you're ready to check your answers. So for my first graph, it is going to be a dotted line because it's greater than. It has a y-intercept of 0, so it started at the origin, and we went down 1, right 1 for a decreasing slope. Now since the origin wasn't available because the line goes through it, I chose 1, 1 as my test point, which meant I replaced y and x both with 1. I got 1 is greater than -1, which is true, so I shaded on the side with 1, 1. For my second line, since it was greater than or equal to, I chose a solid line, and I have my solid line here. I started at the -4 on the y-axis, and I rose 1 and ran 1, connected with a solid line. The origin is available, and when I plugged that in, I got that 0 is greater than or equal to -4, which is true, so I shaded on this side. So here we're going to investigate what it means for these points to either be solutions or not. So 2, 2, I'm going to go over here, and I'm actually going to plot it. So that means I'm going to go over to up 2. I'll put a point there. And 2, 2 is located in the blue region. It's also in the red region. It's in the overlap. So what I'm going to circle here is that 2, 2 is a solution because it is in the overlapping shaded region. Overlapping shaded region. So for my next one, -4, 2, let's go over here. We're going to go left 4, up 2, and that is in the blue shaded region, but all that means is that it's a solution to the blue inequality. It's not a solution to the red, which means it's not a solution to the system. So it's not a solution because it is not in the overlap. It has to be in the overlap in order for it to be a solution to the system. And then my last one, 0, 0, is right here, right in the middle, which is in the blue, but unfortunately it's on the red line, and so that's actually still not going to be a solution because it's on a dotted line. So it could be in there as long as the red line was solid, but since it's not going to be a solution. So our last task is to draw a system of inequalities that has no solutions, which means there needs to be overlapping shaded region. So I'm going to give you an example, and then I'm going to ask you to draw your own. So for example, I might just draw a line that looks like this, and then it gets shaded on this side. And then I might draw a line that looks like this. And so the key is that these two lines are parallel. And then the other line is going to get shaded on the other side. So there would never be any way for them to overlap. So you'll notice that my lines have an increasing slope, and there's no overlapping in between them. So what I'm going to ask you to do, and what I'll be checking tomorrow, is that you've drawn your own system that does not match mine, and that maybe they have decreasing slopes. So pause the video, take a moment, draw your system that has no solution, and I'll be checking on this tomorrow.